Well, hello and welcome to Brunky Tech. I'm here for another episode of PC Build Series. Today we will be discussing motherboards. So, what exactly is a motherboard? So, it contains various amount of components that really put our PC together. So, ultimately, it first starts off with one printed wiring board, printed circuit board. It's been called a lot, but that's what it is. So what this printed circuit board is, it serves as an interconnect between all the components on your PC. It also has the mounting places or mounting footprints for your IC chips, your resistors, your transistors, your capacitors, your inductors, and so these boards come with a interconnect layer that has traces of copper on it, and it also comes with an insulation layer, which provides protection between the layers. So here we have a PCB layout, which shows the different levels of the printed wiring board. Also shows the vias. What these vias are they are connections between the layers of the board. So you can have a blind via, means it comes in from one direction of the PCB. You can have a buried via where you don't actually see it, and you can have a full via. So these are not only serve as the ability to talk between the layers, they also add the ability to cool down the board. So each one of these layers on the board are strategically placed to allow the engineer to reduce the noise coupling within the board. So usually you'll have a complete ground layer, you'll have a complete power layer that helps isolate the rest of the noise from the board. This keeps your signals clean. These traces on the board are typically strategically placed so that way they can meet the impedance requirement of each IC chip. So the second component of a PCB board, or excuse me, a motherboard that we're going to discuss, is the power conditioning, power regulator, or voltage regulator module. So there's multiple names for this. We can use them interchangeably here, but they are typically referred to as a voltage regulation module, or VRM, on a PCB board, or excuse me, on a motherboard. So what does this do? It ultimately provides filtering on your motherboard. So what it does is it takes that voltage that's provided by the power supply, it provides filtering, it scales it to the appropriate voltage if it needs to. So what it provides is additional regulated power to the RAM, USB, your graphics card, RGB lights, and other. Okay, so when you look at a typical motherboard today, it'll have something that's referred to a 8 plus 1, 8 plus 2, 16 plus 1, etc. power stage. And that'll be mentioned on your data sheet or in the advertisement of the board. So what this actually means is the 8x means you have 8 different power modulators inside your board that provide power to the CPU. So ultimately, why would you do this? So each time the CPU switch on and off gates, it pulls the power draw from that. So ultimately, one board or one IC, ultimately one MOSFET might not be able to handle that power draw as it will get too heated. And so they split up that between several different modules. So you typically have a controller that sends out a signal to each MOSFET, and it signals when to activate and when to deactivate. So this reduces the stress on each one of those MOSFETs, and it keeps the MOSFET cool. So the main power connector is also brought in through the PCB. You can see those on the right. Motherboard gets various power and ground signals coming from that, so it can operate at different voltages. So here what we see on the left is the typical motherboard, right where those power modules are. On the one on the left, it is provided heat sink. So this helps keep those MOSFETs cool so it can provide a steady state voltage out to the CPU. Okay, sometimes people will add heat sinks to their motherboard as shown on the right. So this can be risky sometimes, as these usually do not stick on that well. The thermal pad taping that is applied on these aren't designed to keep these installed onto the board. It's my recommendation that is, if you do try and use these, you have a secondary locking mechanism that prevents these to fall out. So on these power regulator circuits, they also come with inductors and capacitors. So the inductors are typically something like a ferrite bead that provides a choke to the output of the MOSFET to the CPU. The capacitors help with voltage regulation. So when the voltage increases beyond the level, it gobbles a little extra voltage up, and then when the power decrease, or excuse me, when the voltage decrease, it adds additional voltage into the circuit. So what this inductor do, it serves as a choke and removes additional noise within your power signal to the CPU. With these mechanisms, it ensures that the CPU gets adequate power and does not and functions correctly. So each motherboard comes with a chipset. So this used to be referred to as two different chips. You'd have a north and a south bridge. But since that inception, these have been combined into one chip, or the CPU has taken some of those functionalities within it. So as the name implies, this is a lane for communication. As the name implies, this is a lane for communication within your motherboard. So you will have the chipset talk directly to the CPU while it talks to various different interfaces throughout your board. It'll talk to your USB, it'll talk to your USB 3, it'll talk to other various components like your Ethernet, your Wi-Fi, your memory drives like your SATA and your M2, and it'll talk to some of your PCI Express. So some of this functionality is taken over by the CPU, where it directly reads in RAM, your video cards, and your M2 memory. All right, so today we're going to review the B650 Eagle AX motherboard. So what this is an AMD 5 socket. So this supports the AMD Ryzen 700 series processor. It has a power performance of a 12 plus 2 phase digital VRM solution. It supports your dual channel DDR5. It also supports the AMD Expo and Intel XMP memory module support. So what that is an additional boost to your memory stick that allows your RAM to run quicker. It comes with advanced thermal design, M2 guards that ensures stability. And so this motherboard has the chipset AMD B650. It's capable of carrying 4 different memory for DDR5. So it can support DDR5 5200 according to the data sheet. Now with this, it says this on the data sheet, but I would reference online to see if it provided additional support. So it supports up to 192 gigabytes of RAM. So this is dual channel. So you'll have a pair of A's and a pair of B memory in there. It calls out and it does not support non-ECC memory. So what this means is even though your processor can handle this ECC memory, the motherboard cannot. So this board also has PCI Express 4.0, PCI Express 3.0. It can support 4 SATA 6 gigabyte. So the SATA drive is for your memory typically. So you'll have a solid state drive or you'll have a disk drive that you connect to it, and it can connect 4 of those up to it. So this board also has M.2 support. So it also has the SATA RAID, which provides additional support for memory. Has a built-in audio channels of 7.1. Has a max LAN speed of 1 gigabytes per second. So it also supports wireless LAN. It also has other various connectors that you'll need when you build your board. So it also has a form factor of ATX. So what this form factor ATX means is it's the standard board layout. So there's 4 different kinds. There are ATX, ATX Mini, and 2 others. So it says right here it's Windows 11 compatible. Pretty sure it's going to be able to take any Windows that you put in there. Shit, where'd it go? So in summary, the motherboard provides a physical interface for your personal computer. These interfaces include DDR, USB 2 and 3, and USB-C, M.2 drives, PCI Express for your motherboard, the LAN interface, Wi-Fi, power on and reset connections through your case, your RBG control, HDMI, audio in and audio out, various heat sinks throughout the board, the CPU mount, and the CPU cooler mount. So ultimately, when you're selecting your motherboard, the things you really have to pay attention to is you have the correct CPU slot, you have the correct RAM for that, you have which NVMe drive you want to use, you understand what PCI Express and how that can interface to your chosen graphics card, your Wi-Fi and Bluetooth if that's important to you, and also the form factor of your board. So thank you for tuning in today. If you enjoyed this video, please hit the like button. If you would like to see more videos, subscribe. If you have any questions, fill them down there in the comment section. Feedback's always appreciated. You have a nice day.